Hi girls, hopefully this video will help you out with 14.2.2, which is finding the limit of an average rate of change. First I want to just talk to you real quickly about, hopefully you remember, average rate of change is just another word or a synonym for slope. Slope can be expressed many different ways. Some of the ways that you've probably seen are rise over run, delta y over delta x, and y2 minus y1 over x2 minus x1. So it's essentially the change in y divided by change in x. For this unit, we're going to be finding the slope or the average rate of change, but we're going to be using this representation of slope, f of x minus f of c over x minus c, to actually find the average rate of change, the slope. It's just a different version of the same formulas you've always used. Okay, so now we're going to work a couple of problems just to give you an idea of how to handle these. So, for example, if you are asked to find the average rate of change, find the limit as x approaches 4 of the average rate of change of the function f of x minus f of x equals negative 2x squared plus x from 4 to x. What we need to do first is find the average rate of change. From 4 to x. So to do that, first let's assign our x and our c. X is going to be x in this case, and then c is going to be 4. So we're going to use our formula, f of x minus f of c over x minus c, to actually find the average rate of change of this function. So f of x is just going to be negative 2x squared plus x minus f of c is going to be that same expression, but with 4, or our c, as the variable. So this is going to be minus negative 2 times 4 squared plus 4. And I'll hope you notice that, do you see how I have parentheses around that second function? I noticed that a couple of you that have already started these problems, if you made mistakes, some people were making the mistake of not putting parentheses around that second function. Remember, you're subtracting all of f of c. So when you subtract all of f of c, you have to be mindful that the entire expression gets subtracted and that negative is actually distributed. So make sure you pay attention to that. Okay, and so our denominator, x minus c, is just going to be x minus 4. So now, just to simplify this expression, this is going to be what? Negative 2x squared plus x minus, what is that, 16 times 2 is negative 32 plus 4 over x minus 4. So now if we distribute our negative and simplify, we get negative 2x squared plus x plus 32 minus 4 gives us plus 28 over x minus 4. So what we need to do is find the limit. Okay, so our next step here, hold on. Okay, so now what we need to do is, step 2 is to find the limit. So we are looking for the limit as x approaches 4 of negative 2x squared plus x plus 28 over x minus 4. Okay, so now that we're looking for the limit as x approaches 4 of this expression, if you look at the denominator, you'll see pretty quickly that if we plug 4 in for x, we're going to get a 0 in our denominator. So because of that, we need to try to factor the numerator to see if maybe we can cancel some common terms out to see if we can actually get a limit. And maybe this is a situation that would be a whole as opposed to a limit that doesn't exist. So to factor this, if you factor this by split the middle, you're looking for two numbers that multiply to be negative 2 times 28, which is negative 56, and add to be positive 1. So that would be, those two numbers would be what? 7, negative 7 and positive 8. So we'd say negative 2x squared minus 7x, oops, minus 7x plus 8x plus 24 over x minus 4. So now that we've split the middle, if we group, we can factor out a negative x in the first group, and we're left over with 2x plus 7. And then if we factor out a 4 in the second group, we're left over with 2x plus 7 over x minus 4. So that simplifies to be 2x plus 7 negative x plus 4 over x minus 4. And we're going to have to move to a new page here. Okay, so I've gotten this on a new page, and hopefully you see that we got, now we're looking at the limit as x approaches 4 of 2x plus 7 negative x plus 4 over x minus 4. And do you see that we've got x minus 4 and 4 minus x? So since these two terms are opposites, x minus 4 and negative x plus 4, we can replace those with a negative 1. So in doing that, we can rewrite this as the limit as x approaches 4 of 2x plus 7 times negative 1, which simplifies to be the limit as x approaches 4 of negative 2x minus 7. So now if we plug 4 in for x, this is going to be negative 2 times 4 minus 7, which is going to be negative 8 minus 7, which is negative 15. So the limit, back to the very beginning, if we go back to the slide before, the original problem, whoop, that's not it. Well, the original problem, find the limit as x approaches 4 of the average rate of change of the function f of x equals negative 2x squared plus x from 4 to x. That limit was negative 15. And real quick, here's one more problem to work that you maybe want to try working on your own, and then watch me work it. Find the limit as x approaches c of the average rate of change of the function f of x equals 8x cubed plus 7x squared plus 2 from x to c, or from c to x. So again, first we want to find the average rate of change. So we're going to say f of x minus f of c over x minus c. Our x equals x and our c equals 0. So 8x cubed plus 7x squared plus 2 minus 8 times 0 cubed plus 7 times 0 squared plus 2 divided by x minus 0. So this is real quickly becomes 8x cubed plus 7x squared plus 2 minus 2 over x. So do you see, we simplify further and we get 8x cubed plus 7x squared over x, because the 2 plus 2 minus 2 cancels out. So now we're looking for the limit as x approaches zero of 8x cubed plus 7x squared over x. Okay, again, if we just go ahead and plug 0 in for x, we see we get a denominator of 0. So let's see if we can factor the numerator. Quickly, the x squared factors out of the numerator, And we're left over with 8x plus 7 on the numerator and x in the denominator. In doing that, you see that we can cancel the x in the denominator. So we get x times 8x plus 7. And the x goes away. So now we can find the limit as x approaches 0 of x times 8x plus 7. Plugging 0 in, we get 0 times 8 times 0 plus 7, which is 0. So the limit as x approaches 0 of 8x cubed plus 7x squared plus 2 is 0. And again, if you ever want to check that, you can always graph it in your calculator, but remember, you won't really see the limit at 0 because it is a hole and the hole is infinitely small. So you actually can't see it. You'll be able to see limits that don't exist, but you can't see limits that are holes. Hope these problems help. Please email me if you have any questions or need anything else. Thanks.